Alrighty, people. Hello, hello, hello. Alright, what do we got here today, everybody? I think we were writing the equation of tangent lines, right? Last time. FYI, I didn't mention this, but yeah. Do y'all remember earlier this year we did tangent line, and then I asked you to write the equation of the normal line as well. Do y'all remember that? So this was the tangent line. Do you remember what you did for the normal line? What we did once you got the equation of the tangent line, do you remember what you did to get the equation of what they called the normal line? So I'm going to work off of... This was the last question that we did last time. What page was that on? That's a good question. Page 20 maybe? I don't know. Page 20. So the normal line, if y'all remember, is perpendicular. That's the key word, to the tangent line at its point of tangency. Right, the simultaneous point between the tangent line and the function. That's your point of tangency. And remember what you did here? All you had to do was work off of the tangent line equation. Because if it's perpendicular to the tangent line, all you got to do is take the negative reciprocal slope. You remember? Perpendicular lines have negative reciprocal slopes, you know? So you just take the negative reciprocal here of 0.675. So I'll just write it as negative 1 over 0.675. Multiplied by x minus pi over 4. All right, little FYI, I might ask you that, the normal line. Like I said, all you got to do is just take the tangent line slope, negative reciprocal, because it's that same point. Right, goes through the point of tangency. Alrighty, what do I want to do here today? Is it the next page? Oh, actually, let me do part F, and then we'll might go into something else here. We're almost done with this unit, by the way, FYI. I think I just got one more topic to go here, if I remember correctly. But anyway, directions here, write the equation of the tangent line, and we might as well do the normal line as well, right? Why not? To this function at x equals 0. Alright. So remember, to write the equation of any line, right, you need the slope and you need a point. So here it's at x equals 0. So let me do the point first. It really doesn't matter. Right, to get the point, that's your x1, y1, right? If we're doing the point slope form, right, of a line, I'm going to plug in 0 here into the function. Right, the f of 0 is going to equal 1 over sine 0 plus cosine of 0. Sine of 0 and the cosine of 0, remember, all comes from the unit circle. 0 radians here, pi over 2 radians up here. Probably be talking more about that here today. So that point is 1, 0, right? There at 0 radians. So the cosine is the x value, so the cosine of 0 is 1. The f of 0 here is 1 over. Sine of 0 is 0 plus cosine of 0 is 1. All right, so the f of 0 here is equal to 1. So that's your point, right? 0, comma 1. That's my x1 and my y1. And now we gotta get the derivative. So what am I gonna do here to get the derivative? Well, I'm thinking like, all right, do I want to do quotient rule or should I manipulate the exponents here? And I don't know. What do I want to do? You know what I mean by, taking sine x plus cosine x, bring that up to the numerator by raising that to the negative first power. I don't know if that would do much, really. I guess I'll do that. Listen, you want to do quotient rule, and it's gonna be the same thing. So I'm going to, right, this is raised to the first, right? So I'm gonna bring that up to the numerator here and make this y, or maybe I'll do f of x here. Is sine x plus cosine x to the negative first, right? That will change the sign of the exponent. All right, so let's do the derivative now. F prime of x, negative 1 goes in front, right? Keep the inside here, right? Evaluate it at the inside. Decrease the exponent by 1. And now multiplied by the derivative of the inside. Right? The derivative of sine x plus cosine x. The derivative of sine is cosine x, right? Plus the derivative of cosine x is negative sine x. All right, so let's see here. I might move that negative 2 back down. All right. Move this to the denominator. Right, that'll make that a positive 2. So f prime of x is going to be negative 1 multiplied by that derivative of the inside, which is cosine x, plus negative sine x. So I'll just write that as minus sine x over sine x plus cosine x squared. And I might as well distribute the negative 1 in there, right? Do that. f prime of x here is going to be negative cosine x plus sine of x over sine x plus cosine x squared. All right. Yeah, like I said, I don't think it was easy, easier and or less work. You'd get the same thing if you did quotient rule. Right? Think like low times low, right? When you think about the denominators, it would be sine x plus cosine x squared, right? So either way, I thought it might be a little easier to do it like this by manipulating the exponents. All right, anyway, let's plug in 0 now, right, to get the slope of the tangent line. So f prime of 0 will be negative cosine 0 plus sine 0 over sine 0 plus cosine 0 squared. Nice thing is we got sine of 0 and cosine of 0 before, right? Sine of 0 is 0. Cosine of 0 is 1. All right, so this is going to be negative cosine of 0, which is 1, plus 0, over sine of 0, 0, plus cosine of 0, 1 squared. So this is going to get you negative 1 over 1 squared. So your slope of the tangent line is negative 1. So we have the point in the slope. So we'll do the tangent line and we'll do the normal line as well. So y minus y1 is going to equal the slope and then x minus x1. You can leave it like that if you want. Keep in mind x minus 0 is x. Normal line, y minus 1 is going to equal the negative reciprocal, of negative 1, which is 1, and then x minus 0. Alright, so there you go, a little tangent and normal line. Alright. What else do I need to do here? I think we're good with that, right? I've done plenty of those. Right, I think I've done a good number here, right, of tangent lines, right? Just really another step, you get the derivative and just plug in that x value, into the function to get the point. So, all right. What do I want to do next? Oh, yeah. All right. Horizontal tangent, people. For what values of x in the interval from 0 to 2 pi do each of the following functions have a horizontal tangent? All right, so let me set this up for you. I think we talked about this before in another unit, right? Horizontal tangent. What do we know about the slope, right, of the horizontal line? All right, what's going to be the slope? All right, if I give you a curve, right, if I give you a curve here, all right, and let's just say let's just say, for example, right here, draw a tangent line. Right. I know that looks kind of vertical, but you know, this is y equals x squared. So I'm gonna say it's like 4. I'm just making this up. Right. So, you know, whatever. You know, if I say that this is x squared, right? F of x equals x squared. F prime of x, or dy dx, is 2x, right? And let's say, I guess it was 2, right? And f prime of 2 would be 2 times 2, right? 4 is the slope of the tangent line. So if I'm telling you here that the tangent line is horizontal, right? That means the slope, right? The slope is 0, right? I'm giving you the slope. I'm not asking you to find the slope. I'm giving you the slope. So this is kind of like a going backwards question. You know, find the values of x where you have a horizontal tangent. Meaning that the slope is 0. Right? So what I'm trying to say here is that, you know, if you go back to this, you know, f of x deal, being x squared, you know, we found f prime of 2 to be equal to 4, right? So basically what we're going to be doing here, and then I'll set it up in the next part, is I'm giving you the slope. Right? I'm telling you that the slope is 4. And you got to find at what x do you have a slope of 4? Right? We're so used to me giving you, you know, the value of x to find the slope, but I'm giving you the slope, and now we got to